What would happen if a world frozen for billions of years was actually hiding a living ocean beneath its surface? Mimas, Saturn's tiny moon, only about 396 kilometers wide, was long believed to be a lifeless block of ice at the edge of the solar system. But then, data from Cassini revealed something terrifying. Mimas is wobbling far more violently than a normal solid celestial body should. That could only happen if its entire icy crust is floating above a vast liquid ocean buried deep below. An ocean that has never revealed itself. A world pretending to be dead in the darkness of Saturn. With a diameter of only 396 kilometers, Mimas is one of the smallest moons in Saturn's system. It is also the smallest object in the entire solar system, massive enough to pull itself into a nearly perfect sphere. And that modest size is exactly what makes it so extraordinary. In images captured by Cassini, Mimas looks almost identical to the Death Star, the superweapon from the Star Wars series. The resemblance is not a coincidence. It comes from the Herschel crater, a gigantic scar nearly 130 kilometers wide, covering almost 1/3 of the moon's total diameter. It is one of the largest impact craters relative to the size of its host body anywhere in the solar system. Mimas also possesses a network of fractures stretching across its surface. If that impact had been only slightly stronger, Mimas could have been completely shattered into millions of icy fragments orbiting Saturn. But somehow, it survived. Today, scientists view the Herschel crater as a kind of historical thermometer. The crater walls remain sharply defined, suggesting that at the moment of impact, the ice inside Mimas had already begun warming and transitioning into ductile ice, a tougher, more flexible form of ice capable of absorbing massive impacts instead of shattering apart. That means the internal transformation of Mimas had already begun long before humanity ever discovered it. When Cassini mapped the moon's surface temperatures, scientists were even more shocked. Instead of heat being distributed according to normal sunlight patterns, they discovered a strange C-shaped region resembling the character Pac-Man. From a physical standpoint, this Pac-Man region should not exist. Areas that should have been warmer were unexpectedly colder, while some darker regions retained heat for unusually long periods of time. It was a clear thermal anomaly. The true cause lies in the brutal environment surrounding the moon. Mimas is constantly bombarded by high-energy electrons trapped inside Saturn's enormous magnetic field. These particles have effectively baked the icy surface, altering its crystal structure on a microscopic level and transforming it into a dense armored layer of ice capable of storing and releasing heat in bizarre ways. The most important discovery about Mimas came from analyzing its orbital motion around Saturn. By tracking how Mimas rotates and oscillates through space, scientists discovered that the moon wobbles far more violently than expected for a normal solid icy body. This phenomenon is known as libration, the small oscillations that occur as a moon orbits its parent planet. Normally, if Mimas were completely frozen inside, the entire moon would rotate as one unified solid object, and the wobble would be very small. But Cassini's data showed that Mimas is shaking much more dramatically than predicted. That can only be explained by a mechanism known as a slipping shell. According to current models, Mimas's outer icy crust is about 20 to 30 kilometers thick. Directly beneath that crust lies a global liquid ocean trapped between the ice shell and the rocky core at the center. This layer of water acts like a cushion, preventing the ice shell from being tightly locked to the inner core. As a result, the shell can oscillate and move almost independently while Saturn's gravity continuously stretches the moon. You can imagine it like a raw egg. When you spin the egg, the outer shell and the liquid inside do not move perfectly together. Mimas may be behaving in much the same way. Do not let Mimas's silent appearance deceive you. If Enceladus and Europa are the loud moons, constantly displaying violent geological activity, then Mimas does something far more disturbing, a silent one. Enceladus has its famous tiger stripe fractures that continuously erupt towering jets of water vapor and ice hundreds of meters into space. Europa's surface is covered in cracks caused by the constant stretching and recycling driven by the ocean beneath. But Mimas? Nothing at all. No young fractures, no plumes, no visible signs of escaping heat. Its entire surface is covered only in ancient impact craters, gray and lifeless, like a world that died billions of years ago.
And that absolute silence is what makes the discovery so shocking. Mimas may be hiding a massive liquid ocean beneath an ice shell 20 to 30 kilometers thick, while leaving almost no trace of it on the surface. You are looking at what appears to be a frozen corpse, but deep inside, the ocean may still be alive. So what has kept the ocean beneath Mimas from freezing solid for millions of years? The answer lies in Saturn's enormous gravity. Mimas does not orbit Saturn in a perfectly circular path. Its orbit is slightly elliptical. That means the distance between Mimas and Saturn constantly changes, creating cycles of stretching and compressing across the moon, like a rubber ball being squeezed and released over and over again. The friction generated by this process is converted into heat, a mechanism known as tidal heating. Even though the amount of heat produced during each cycle is relatively small, it accumulates over millions of years. More importantly, the process amplifies itself. The warmer Mimas becomes, the easier it is to deform, and the more heat it generates in return. Scientists call this a tidal feedback loop. Mimas is not acting alone. It also plays the role of a crucial shepherd moon, helping maintain the Cassini division within Saturn's ring system. Today, Mimas is locked in a 2-to-1 orbital resonance with the moon Tethys. These resonances, along with recent inward orbital migration and chaotic resonance events in the distant past, have helped preserve the moon's orbital eccentricity. As a result, tidal heating remains stable enough to prevent the hidden ocean from freezing solid. In other words, Mimas is not only being squeezed by Saturn, It is also being silently supported by the entire surrounding moon system. The latest studies from 2025 to 2026 revealed an even greater surprise. The ocean beneath Mimas may actually be very young. It likely formed only around 2 to 25 million years ago, extraordinarily young compared to the solar system's 4.5 billion year history. That explains why the surface of Mimas still preserves its ancient appearance, covered in impact craters without massive fractures cutting across it. The internal heat simply hasn't had enough time to completely break apart the old icy crust. We may be witnessing an incredibly rare transitional moment in cosmic history, the point at which a world once thought dead is beginning to awaken. This hidden ocean may also function as a gigantic shock absorber. When massive impacts strike the surface, the liquid layer beneath can absorb and dampen seismic shock waves, preventing Mimas from completely fracturing apart. That may be why even the colossal Herschel crater failed to destroy the moon. And this opens up an enormous possibility. Many other moons that appear dead, such as Miranda and Ariel around Uranus, or several icy moons orbiting Jupiter, may also be hiding similar oceans beneath their frozen surfaces. So what will happen to Mimas in the future? Today, Mimas is often described as an Enceladus waiting to awaken. In the future, if the icy crust becomes thinner or tidal heating grows stronger, Mimas could eventually begin erupting towering plumes into space. On the other hand, if its orbit gradually becomes more circular, tidal heating would weaken and the hidden ocean could cool and freeze once again. The fact that Mimas's ocean appears to be so young also creates a major challenge for future exploration missions. Scientists must strictly follow the principles of planetary protection. Even a tiny amount of bacteria from Earth could contaminate this pristine, newly formed environment, potentially disrupting or destroying the primitive chemical reactions taking place there. Because of that, every spacecraft, especially landers or ice drilling probes, would require extremely rigorous sterilization procedures. If all of this is true, then the universe may be filled with pretending to be dead worlds, dark frozen shells on the outside, while deep within, liquid water, heat, and primitive chemical reactions continue to survive in silence.